Alright, this video is a continuation of page 6 of Notes 2 from Calc C. Still talking about geometric series, and because of that, this formula is going to be super important to us. So the sum, first term times the ratio to the nth power, is the first term over 1 minus the ratio. And really we're just going to use that over and over again, do some algebraic stuff, look at intervals of convergence, but let's get started. So what we have is we have functions, and we want to write geometric series for them. So what I'm going to do is I'm going to rewrite this so it looks like that formula. I mean, it kind of looks like 1 over 1 minus x maybe, but I need to rearrange it. So it's 1 over 1 minus negative x. And then if I worked backwards from that, I would end up with the original, so I know I haven't broken any rules yet. So once I've written something like that, I can rewrite it as a summation. So from 0 to infinity, first term, ratio to the n. And from there, what I like to do is I like to leave nothing in parentheses. It doesn't need to be in parentheses. So I rewrite it as negative 1 to the n, x to the n. And then I need the interval of convergence. So to do that, I go back to the ratio, which is negative x. And I know that the absolute value of the ratio needs to be less than 1, which in this particular case means that the absolute value of x needs to be less than 1. And that's all there is to that particular problem. So let's go on to B. So in this case, our function is 1 over 1 minus 3x. And I'm going to continue to just kind of color code these with the first term and then the ratio. So in this case, the first term is 1, the ratio is 3x, because I already had a minus there. So in some ways, this might even be easier. So 0 to infinity, 1 times 3x to the n, which I'm going to again separate into 3 to the n and x to the n. I don't know if, how important that is. I just do it all the time. It's kind of a habit that I have. So I need a ratio, an interval of convergence. So I look at the ratio. I know that the absolute value of that needs to be less than 1, which means that the absolute value of x must be less than 1/3. So there you go. Let's move on to the next one, which kind of takes it up a notch, so it's a little more difficult. So f of x is 1 over 4 minus 2x. So this one kind of breaks the mold because that bottom left thing there is a 4 and not a 1. So my goal is to turn that 4 into a 1. The way I'm going to do that is I'm going to divide every single thing that I see by 4. So 1 over 4, 4 over 4, and then negative 2x over 4. So that'll give me 1/4, 1 minus x over 2 by simplifying. And let me color code that so it looks like I'm used to it. So at this, and at this point I can write my summation. So it's from 0 to infinity, first term, ratio to the nth power. Now what I'm going to do is, so 1/4 is 1 over 2 squared, and then x to the n over 2 to the n, so break everything out. And then I can kind of combine some things. So I get x to the n over 2 to the n plus 2, because remember, same base multiplying, you add the exponents. But again, I need an interval of convergence. So I go back to the ratio. Absolute value of x over 2 is less than 1, which means the absolute value of x has to be less than 2. And that's what I get. So you might be wondering, how do you have any idea if you're correct or not? So what I propose is that on your calculator, I define the original function. So that's 1 over 4 minus 2x. And then I define the summation. So the calculator can't really deal with an infinite number of terms. But generally speaking, if you use 100 terms and you're correct, you're going to get a really good result. If you're incorrect, you'll also get a really bad result by then. So I'm going to just define the sum from 0 to 100 of what I think my series is. And then I like to just graph. So you can see on the graph that the two functions are almost completely overlaying each other on the interval from negative 2 to 2. So I do change the window to make it look kind of correct, which I suppose you should do in these sorts of circumstances. Let's move on to the next problem, which is very similar to the last one. So again, I'm going to divide everything I see by 2 to make sure I have a 1 in the bottom left. So 4 over 2, 2 over 2, and 8x over 2 gives me 2 over 1 plus 4x. I'm going to rewrite it because remember I need a 1 and I also need a minus in the denominator. Those are really the key things. If you can make those happen, you can kind of do the problems without an issue. So now I know the first term is 2, I know the ratio is negative 4x. So I write it as a summation. So first term, ratio to the nth power. I'm going to do the thing where I kind of pull everything apart. So negative 4x is really negative 1 times 4 times x all to the n, so it's negative 1 to the n. 4 to the n, x to the n, but I'm going to make 4 into 2 squared to the n, so 2 to the 2n. You'll see that happen. Or at least you'll see the end result of it. So if you didn't follow that, I don't know, rewind. So we have this, and then I can collect a lot of like things, like bases, I guess. So I get negative 1 to the n, 2 to the 2n plus 1, x to the n. But again, I need an interval of convergence, otherwise I won't really know where this is useful. So the ratio is negative 4x, so I need the absolute value of that to be less than 1, which means that the absolute value of x is less than 1/4. And again, I'm going to check it on my calculator. I'll just show you the screenshot here. So I've graphed the original function. I graphed from 0 to 100. I usually go with that. The calculator is pretty fast these days, so that's not really a burden. If your calculator is too slow, go 0 to 50. 0 to 20, honestly, will probably give you a pretty good result anyway. New problem. So f of x is 4x squared over 1 minus 2x. This one's actually set up, like there's nothing for us to do. Let's just color code it. We'll write our summation and kind of move on. So this one's ideal. It looks really difficult initially, but it's first term, ratio to the n. Lots of things. So 4 is really 2 squared, so I get 2 squared times 2 to the n is 2 to the n plus 2. And then I have an x to the n plus 2. But I need the interval of convergence, so I go back, I get my ratio is 2x. Absolute value of that less than 1 tells me that. So I have a really limited interval on which this series converges for this function, but it still does it. So let's take a look. There you go. So original function out to 100, they overlap. I changed the window. I think I went like negative 1/2 minus 1/5 to 1/2 plus 1/5, and I just typed that in. I don't even like figure out those values. Calculator does it for you. To get a good picture. New problem. So f is, again, this one's almost done for us. I don't have a 1 in the lower left corner, so I'm going to divide everything I see by 3. So I have x over 3, 1 minus 2x over 3. Let's color code it. You obviously don't need to color code when you're working at home. Let's write it as a summation from 0 to infinity. Got x over 3, 2x over 3 to the n. Pull it apart so that, nothing's in parentheses raised to the n, which again, may be just a habit that I have. So I get 2 to the n, x to the n plus 1 over 3 to the n plus 1. And interval of convergence. So I go back, I get r. Absolute value of 2x over 3 is less than 1, which means that the absolute value of x is less than 3/2. And again, to check myself, I like to graph. So there's a graph. Does a really good job. You can see, if you do enough of these, by the way, you'll notice that the interval of convergence has a lot to do with the center, which in this case is 0, the center and the vertical asymptote of the original function. So if you go back and look at the previous ones, you might notice that there's definitely a pattern there. Do enough, you notice that, and it kind of makes your life a lot easier. Okay, the next question is a little different. So what I want is a series for 1 over 1 minus x, but I want it in powers of x plus 3. Okay, so what does that mean? That means that I'm going to end up writing a summation. It goes from 0 to infinity. Some coefficient, which I'm just calling c sub n, so it might be a function of n, we don't really know. And then times the quantity x plus 3 to the n. So I want r to end up as x plus 3. So let's see what we can do for that. So I'm going to start with 1 minus x, and what I'm going to do is I'm going to use a trick where you add 3 and subtract 3. The reason I do that is because now I'm capable of manufacturing an x plus 3. So now I need to rearrange this in such a way that I get an x plus 3. So what I do is I take the plus 3 that I'm adding. So again, if you add 3 and subtract 3, you're not really doing anything, you're just changing the way it looks, and for our purposes, that's really useful. So I've rearranged it so that when I factor the negative coefficient of x out, I end up with an x plus 3. So I'm going to go with 4 and then minus the quantity x plus 3. So it's like a grouping type deal on the two right-hand terms. Now there's a problem that I've done basically a lot. I'm going to divide everything I see by 4, color code as I go, write my summation. So first term, ratio to the nth. And now I need to find the interval of convergence, which is, well, actually, let's rewrite it, pulling everything apart. So So you can see there's my x plus 3 to the n, so that gives me my in powers of x plus 3, so that's good. But I need the interval, so r in this case is x plus 3 over 4, so that has to be less than 1, which means that the absolute value of x plus 3 has to be less than 4, which means the way that I think of this is that you're centered at negative 3, and you go 4 in either direction, so you can go all the way to negative 7 on the left, and you can go all the way to 1 on the right. So I don't actually solve that, I just kind of logic it out. And if you take a look at a graph, it does a really good job. It has a very wide interval of convergence, which is kind of why you might want to do something like this. It's more useful over a wider interval. But of course we change the center from 0 to negative 3, so if you're really interested around 0, you might as well center it at 0. But these are issues you run into. Also, most of the problems you're just going to be told what to do. So let's do it again in powers of x minus 4. It's going to be almost exactly the same thing. So I'm going to do plus 4 minus 4. I'm going to rearrange it so that I end up with x minus 4 in parentheses. So in this case, I put the minus 4 with the 1 and then the plus 4 with the negative x. I'm going to combine and then factor. So I have this. Divide through by negative 3. So I get negative 1/3 minus the quantity x minus 4 over negative 3. You could have distributed that negative and made it plus, but then you would just have to factor it out again, so not really worth it. And summation, because now I know first term, I know the ratio. So there we go. And now I'm going to pull everything apart. So I end up with negative 1 to the n plus 1. That's coming from the fact that I have negative 1 over 3, so that's 1 negative 1. And then negative 3 to the n is really negative 1 to the n and 3 to the n. And it doesn't matter if negative 1 to the n is in the numerator or the denominator, so I bring that from the denominator up. That's where that comes from. I feel like that's the most confusing part of this. Let's find our interval. So in this case, I'm going to be centered at 4, and I can go 3 in either direction. So to the left I go 3, I get 1. To the right I go 3, I get 7. And if we look at a screenshot of the calculator, you can see that it overlaps it really nicely on that interval. So it worked out. I hope you found this helpful, and good luck.